Quantum cryptography, quantum experts, cryptographers and programmers working together on the maximum possible degree of security of the transfer of random keys for the encoding of confidential communication. That means sending a key from A to B with the absolute certainty that this key will not be tapped. What sounds so simple has been an unsolved problem since antiquity. SECOQC, a European project with 41 partners across 12 countries, coordinated by the Austrian research centres. In 4.5 years of work, a new technology emerged from the laboratory into reality. 6 different systems can now seamlessly work together in order to find it. A quantum key to the future. Be it bank business, online trading or project development, ever more and more important, data is in our days being transferred electronically. Projects are developed, worked on and finalized digitally. Take this new skyscraper being developed in a small company in Vienna a few years from now. As usual, time is running and absolute connectivity is required.
Hallo? Ja, ist unterwegs.
However, this should not imply a loss of security of data transfer. In order to keep sensitive data private, it is encoded with keys. The data which should be sent to the boss out of office, in our case plans and pictures of the new project, is to be protected. To achieve this, it is encoded, in our case, put simply, covered with a matrix. Only those who have the matching key will be able to see and to read the picture again, so the data can go on its way to the cafe.
Naja, die normale Kryptographie, die heutzutage verwendet wird, um Schlüssel auszutauschen, die asymmetrische Kryptographie, kann von einem Tag auf den anderen unsicher sein oder nicht mehr sicher sein. Es ist nicht mal bewiesen, dass es keine Verfahren gibt, mit denen das auf algebraische Art und Weise leicht geknackt werden kann.
So far so good. Such encoding is of course already in everyday use. Data is encoded and made unreadable. But how can one ensure that the addressee of the message really is the only one with the key? The only one able to read the message? How can one protect oneself from attacks? And where can one take the absolute certainty from that an attempt tap will really be detected, like one used to be able to hear a tap on the phone from the noise?
The basic idea is that in quantum mechanics you cannot observe without perturbing what you are observing. And this is a trick in a very simplified sense, which is used for quantum cryptography.
It all comes down to one question. How is the secret key transferred? So far, the systems transporting the keys are safe, but it is quantum physics itself that is opening the old keys up to attacks by making supercomputers possible in the near future. These supercomputers will have such a high capacity that they will easily tap into systems that have so far been safe. The safety of quantum cryptography in the transfer of the key rests on laws of nature rather than on mathematical problems that are difficult to solve.
Quantum cryptography, on the other hand, has the potential to offer provable security because it's based on quantum physics. The only assumptions we make is that quantum physics works, and if it works, then you can guarantee the security.
Back to the future. In the case of the skyscraper project, the architect can obtain a fresh key even in a cafe. He decodes the picture and is sure that no one else has seen the key yet. Safe keys, safe data. This is confirmed even before the data is successfully decoded. Although this application still lies in the future, the year 2008 will bring the breakthrough for this level of security to become reality. That is surprising indeed, because only a few years ago, not even the quantum experts themselves expected it.
It was such a radical revolution, this quantum physics, that actually even the physicists during many decades didn't realize that this new physics not only brings paradoxes or counterintuitive situations, but opens new possibilities.
The SECOQC network centered in Vienna is the first fully functional prototype of a quantum cryptographic network.
Hi, this is Julia, may I speak with Cryptography, please?
Since 2004, the Austrian research centers have been coordinating from their offices in Vienna their project partners who have worked on, researched for, and developed the quantum cryptography network. The project was concluded with the presentation of the first network of its kind in Vienna on October 8, 2008.
Алло. Здравствуйте, Олег Николаевич. Я сейчас ваши все формуляры просмотрел.
6 network nodes connected to each other via 8 optical links. This development project was able to unite almost all European players in quantum cryptography in order to make the technology available to users in a short time. Many technical problems had to be solved, different disciplines coordinated, and appropriate network protocols and standards had to be developed.
There's quite a language gap which has taken some time to overcome. We've overcome it within this network and have created something which is truly multidisciplinary in the SECOQC network.
A Viennese research lab for quantum physics in the mid-90s. Here, as in many other labs of the current project partners, the first keys are being created from single photons and are exchanged via fiber optic cable. Each observation of a photon leaves unmistakable traces thanks to the laws of quantum physics. A tap will be discovered immediately by the system, one of the conditions for the safe distribution of keys. What was only possible in a lab just a mere few years ago, today works in a perfectly normal PC-like case. Inside, the technology remains a high-end solution, but from the outside it is simply plug and play. In the last 4 years, the SECOQC project has brought a breakthrough. The different systems, developed in different labs, cooperate. For example, when one of the transfer paths in the network fails, another connection will take over the transfer of the key. Beyond system stability, the network also provides the possibility of exchanging keys across greater distances than the 100 kilometers or so to which point-to-point quantum cryptography is in principle limited to. Within the network, keys can be passed on along greater distances and at higher rates by using parallel paths, bringing the technology one step closer to everyday use.
Nowadays, with the results of SECOQC, we can have QKD networks where numerous different partners can connect to a network, know only their immediate partners, and still be able to communicate with the same degree of security across the whole network.
And also we extended the capability of QKD by making it was limited in distance. With the new architecture we have, we keep the security, but extend it to long distances.
Ja, hallo, wie läuft's?
Hier läuft alles bestens. Schick mir die Pläne einfach rüber.
Ja gut, dann sende ich dir jetzt die Daten.
The architect in the cafe will in future be able to rely on a quantum network. Even today, data is transferred within seconds, 1 billion times a day. Every day more money and more important informations are involved. Not only important building projects, but health data or maybe even the electronic elections of the future. That really requires highest system security. Today's systems are not sufficiently tamper-proof. And more often, third parties try to get to data.
L'application de la cryptographie quantique, et plus spécialement de tout ce qui est distribution de clés quantiques, peut être très importante quand on a des informations de valeur critique à sécuriser. Et notamment quand cette information ne peut pas être assurée. Il n'y a pas de valeur monétaire associée, par exemple, à une information liée à un vote qui pourrait se faire via Internet. On ne peut pas assurer la perte ou la modification de cette information et ça touche effectivement au principe démocratique. On peut pas jouer avec la sécurité de ce type d'information.
The machines have been tested in the Tech Gate Vienna again and again. Now they are being disassembled because all 6 systems are to be taken to different locations for the event. years of intensive work will find their big finale.